So this is the 2009 question 3, part B. So it's motion on an inclined plane and project down an inclined plane. So this is a slightly different one than the previous example. So our inclined plane, and for this one, is projected down. Now we're told a few little things about it. We've got the incline has an angle of theta, and we've also got that the projection angle then, so I'm just going to go for the object is projected like this at an angle of 2 theta. So what we have to look at here, well, there's a few little things we must think about first. We know that's 2 theta, we know this is theta. We have to get our 4 things, we have to get our question set up. So the way we do that is we get a value for ux, uy, ax, ay, vx, vy, and then sx and sy. What are each of these equal to? We know this here, I'll just put it as u is inclined over there. That's what u is, that's the magnitude of the initial velocity vector. So ux will work out simply to be u cos of 2 theta. You'll see it in the previous videos, it explains exactly where that comes from. Uy is sine of 2u theta. Now ax and ay, we have to be very careful here in this for this instance. So I'll go with black. Actually, I'll go like that. So gravity is acting straight down like this throughout this experiment, or throughout this setup. Now what we'll want to do is we'll want to get this in terms of in our new reference frame, which is up in that direction and down in that direction. Now you'll notice that gravity won't be decelerating the velocity moving down, it will actually be increasing the velocity. So that'll be plus going down and minus in the vertical direction. So I'll just show where that comes from. If you imagine that gravity will be coming directly down, we can express gravity as a component directly perpendicular in the y component there. So if I put black, so this is g. This would be g in the y direction, or the acceleration in the y direction is this red vector here. And then we also have a vector perpendicular to the plane here, which would be a in the x direction. This angle here is theta, it's the same as this angle. So what we've got here is that if you just use this right angle triangle, you'll see that in the y direction it'll be negative. So this is the y direction, this is negative in the y direction, and it'll be positive in the x direction. So acceleration in the x direction is going to be, I'll put a plus there, it's really the most important part of this question, plus g, and it's the opposite from the theta, so it's g sine theta. And then the acceleration in the y direction is minus g cos theta. So once you get that with these, so this is projected down an inclined plane, once you understand that the signs change, because it'll be accelerating in the x direction now. Vx then, you know that v is equal to u plus at, and for the next one will be s equal to ut plus 1/2 at squared. So we'll just sub in what we have here. So for Vx, Ux is just u cos 2 theta plus 1/2 at squared. So it will be plus 1/2 a, which is acceleration, g sine theta t. No, it's not a half, it should be just g sine theta t. Vy similarly is u sine 2 theta minus g cos theta t. Just coming from this equation here, whatever the uy and ay are equal to. S of x then is equal to, and this will be the same as the range, which comes into the question. So the range is ku squared over g. So the S of x is equal to, we'll sub that in now, ut, which is u cos 2 theta times time, plus a half at squared. So it's 1/2 a g sine theta t, and uy, and this is going to be equal to 0 because when it hits the range, y value will be 0 down here in the diagram. So that's in our coordinate system, the y value will go to 0. So S of y will be equal to ut again, which is u sine 2 theta t minus 1/2 g cos t squared. It should be t squared there. So we're well on our way here. So first we have to do is, we notice that in our answer we want to show that the range is ku squared over g sine theta. There's no time in that, so we have to get rid of time. The way you get rid of time is you look here at the S of y equation. So when at the range, S of y will be equal to 0. So this whole equation will be equal to 0. So u sine 2 theta t minus 1/2 g cos theta t squared will be equal to 0. Solve for t, so we have a substitution for t. We can sub that back into S of x to find the range in a second. So we take t out, we get u sine 2 theta minus 1/2 g cos theta t is equal to 0. So either t is equal to 0 or u sine 2 theta minus 1/2 g cos theta t, that should be squared, shouldn't it? Yeah, that should be squared, is equal to 0. I'm doing a different colour, that's a little bit hard to see. Oh, it shouldn't be squared, sorry. I factorised that t out. So t is equal to 0 is at the start, that's when S of y is equal to 0, so we just ignore that one and we'll work with this one here. Bring that over, we get, or just bring the u sine 2 theta, subtract that from both sides, multiply across by minus 1, and you get a 1/2 g cos theta t is equal to u sine 2 theta. Probably skipping a line there, but it's correct. We'll go here then, multiply both sides by 2 to get rid of the half. We get g cos theta t is equal to 2u sine 2 theta, and divide both sides by g cos theta, and we get time is equal to 2u sine 2 theta all over g cos theta. Now, it's very important you have familiar with your log tables. I'll do this one in black up here. So, if you look on whatever page is page 18, is it?
14.
Page 14 and 15, the sine of 2 theta is equal to 2 cos theta sine theta. So we can substitute that in. That's correct there, isn't it? So when we substitute this in, we get t is equal to 2u, 2 cos theta sine theta all over g cos theta. We can divide that cos theta in there, and we get a value for this one here of 4u sine theta over g. So that's where time is equal to. Now we can substitute this in for S of x. So I'll just put a line down here. We're well on our way there now. So we know S of x is equal to, or the range will be equal to u cos 2 theta t plus 1/2 g sine theta t squared. So we substitute in the 4u sine theta over g for t. And we get the range, or S of x, is equal to u cos 2 theta, I'm just putting in a different colour, times 4u sine theta over g plus 1/2 g sine theta, and it's 4u sine theta over g squared. So multiplying this out, just grouping them together, and we'll see what we end up with. We have here, and that should be half at squared. That's correct. U cos 2 theta, I'll just write that up here, is also equal to, is it cos squared theta minus sine squared theta? I'll just check it there. Cos 2 theta, it should be just above the sine.
Cos 2 theta is cos squared theta minus sine squared theta.
Minus sine squared theta. So we'll substitute that in for cos of 2 theta just to get rid of it. So we have cos squared theta minus sine squared theta times 4u sine theta over g. I should have probably multiplied the u's in there, but I'll do that in the next step. We notice here that this is also going to be equal to g. When we square that out, we have, I might as well, this is plus 1/2 g sine theta, and squaring everything in the brackets, we get 16u squared sine squared theta all over g squared. Now, I'm just going to change a few things here. So that u there, we can call that squared. This g squared will cancel with this g here. This 2 will divide into 16, gives us 8. And we've got 2 fractions now. So where are we with this? We have now, and I'll just try to write it as small as possible, we have, I'll do it in black, u squared bracket 4u squared, and I can multiply the sine in as well, sine theta cos squared theta minus 4u squared sine cubed theta all over g plus, and this will be equal to, let's see, where are we with this one? We have 8u squared sine cubed theta all over g. So we can subtract these, we can add these two together. So really we're at because of the same common denominator, we're very close to the end of this question now. It'll just be a matter of factorising out something and just manipulation to get our answer now. So we can add these two because of the same common denominator, and we notice we've got 4u squared sine cubed and a plus 8u squared sine cubed, so that will make plus 4u squared sine cubed. So we'll just do this here. We've got 4u squared sine theta cos squared theta, so I'm just going to circle this bit here, we'll add to that bit there, the same common denominator, and you're just left with plus 4u squared sine cubed theta, and this is all over g. Now, if we just factorise out at the top, we'll see we have 4u squared. If I take 4u squared sine theta out, I have cos squared theta plus sine squared theta. This is all over g. And you'll notice that cos squared theta plus sine squared theta is equal to 1. It's one of our main trigonometric identities. So we have our answer then, that range is equal to, and I'll just do it in green so it's just a little bit clearer, range will be equal to 4u squared sine theta all over g, and it's asking for k. We're told in the example that we've got, it should work out, the range should work out from the question, let's put it here, the range should be equal to ku squared sine theta over g, and we know that our answer has to be 4. K has to be 4.